this again. Okay, video 92.
It is. We are getting ready for difference of proportions. See those things?
They look fun.
We're going to get there soon.
Okay. So, here we have kind of a review.
Back in the day.
Okay. So we have x and y independent variables, and the mean of x is 34, standard deviation 9. Y, the mean is 16, standard deviation 5. So we want to find the expected value of x minus y.
Right. So remember, expected values are beautiful. If we're subtracting the random variables, we just subtract their expected values.
Right. So it'd just be 30 more minus 16 or 18.
Cool. Standard deviations do not add or subtract. You have to work with variances.
Yes.
And variances always add.
Right.
Okay, so let's find the variance of x minus y first.
Well, so we have 81.
Yep.
And we have 25.
And you got to add them. Variances add. And
Okay.
they have to be independent variables. So
So
you get 106.
106.
And so the standard deviation is the square root of that. And that's 10.29. Okay. Now, here's the new fact. If x and y have normal distributions, so does the difference. So this we didn't talk about before. And this is very special to normal distributions. It's the only distribution I think that has this property. So if we look at the probability x minus y is greater than 25, we can use normal CDF for that because x minus y has a normal distribution with mean 18 and standard deviation 10.29, which we just found.
Right.
Okay, so we use normal CDF, lower limit 25, upper 100,000 or something big.
Yep.
The
18.
18 and 10.29. And you just do it. There's a 24.8% chance that x minus y will be greater than 24.
248.
Or greater than 25.
Nice.
All right. Here's the puppy and cat problem. Okay.
Oh, this looks familiar.
Yeah. So, well, there are two like this. So, the American Veterinary Association claims that the annual cost of medical care for dogs averages $100, standard deviation 30, and for cats 120. I wonder why cats are more expensive. It's pain.
They're needy. I
Yeah,
guess.
sit on them or hold them down. You get clawed more. I don't know. But cats are more
They
expensive.
live longer.
Standard deviation 35. All right. Well, they're smaller. They get
Okay,
tinier
so
parts.
expected difference, well, that's just
Yeah, difference in cost.
120 minus 100. We're just going to keep it positive.
So we're gonna do cats minus dogs in this problem. Okay.
$20.
$20 average difference. Now standard deviation again. We gotta find go through the variance.
Yes. So 30 squared
Right.
plus 35 squared
Right.
was what?
I don't know. I skipped that step.
Oh, okay. Yeah. How about we just do this? Square root.
I got it. Hang on. It's a square root of 2125. 2125.
Okay.
Which is 46.1.
46.1.
Okay, so that's the standard deviation of the difference in costs.
Yes.
On average, $20 difference, and that's the standard deviation. Okay, suppose the veterinary costs for dogs and cats are independent and can be described by normal models. All right, so now we can assume the difference is a normal model.
Yes.
Okay, what's probably the expenses are higher for someone's dog than for a cat. So could you write D greater than C?
Right. D greater than C. Well, doing some algebra.
Yeah, that would mean that C minus D
C minus D.
is less than 0. So why do we do that? Because our random variable is C minus D. So if the cost for a dog is bigger, then that means C minus D would be less than 0.
Yes.
So we had to write this in terms of what we already did.
Okay.
Okay, and
I'm there.
all right, so now you want to draw a normal curve?
I can.
The average difference in cost is 20. The standard deviation is 46.1.
Okay.
And we're interested in this being less than 0.
So
0 is somewhere over there.
Yeah. So around here, and we want less than that.
And maybe up here put C minus D. That's the distribution of C minus D, the difference in the cost.
Okay.
Okay, so if you use normal CDF, you end up with 33.2%.
33.332.
Yeah. All right. So about a third of the time, the dog's going to be more expensive. Okay, next.
Okay.
All right.
Rolling through.
A little bit more. So here we
Still
have
depends.
same cost, same setup, but suppose someone's going to get 2 dogs and a cat.
Mm, two
Right.
dogs and a cat.
That's kind of a
That's-
miserable house for that cat.
Yeah.
All right, so describe a model for the cost. So, all right, let's find the expected value. So
Okay.
put a big E,
E.
and then we're going to do D1
Oops. I'm sorry. D1.
plus D2 plus C.
Oh,
Remember the
I was going
subscripts?
to do 2D, but that's okay. I got you now.
2 of these actually wouldn't quite be correct.
Oh, that's right.
Remember, in the stats, variables don't work that way. We have 2 instances of dogs.
Yes.
So that's why we use subscripts. All right. So we're okay. So the expected value would be the same, but the
Yes.
standard deviation would be different that way. All right. So it's going to be your $100 plus $100 plus 120,
120.
$320.
Okay. And now,
Variances. So big square root.
big square root.
So find the standard deviation. Take the square root of the
30
variances.
squared plus 30 squared
Plus 35
plus
squared.
35 squared.
Miraculously, this works out to a nice even 55.
Okay.
Expecting a big decimal.
Okay.
Now, since we're assuming that they have a normal distribution, when you
Mhm.
add the distribution for 2 dogs and a cat, it has a normal distribution. And so to answer this question down here, what's the probability that your total expenses will exceed 400? We can use the distribution we found. That's
Okay.
the distribution of total costs.
So,
And I got 7.3% of the time.
7, 3.
All right, so it's really just a matter of finding expected value and standard deviation
Yes.
and using a normal curve.
Mm-hmm.
All right,
Okay.
now, this is getting closer. Great movie. Birdman, it's about an old guy like me.
Yeah. Well, you guys need those movies. Keep you going.
All right,
All right.
you'll get there 20, 30 years.
So we have our sample proportion for males. So that was 0.57.
Yeah.
Okay. And if you figure out your standard deviation, that ended up being 0.03.
Wait, first off, what was this all about? Oh, 57% of males,
And 60% of females agree that Birdman was the best picture.
and we took 2 samples. So
Yes.
a sample of 300 males and 450 females.
Uh huh.
Okay, so this is a distribution of, let's call this P1, P1 hat. We'll let the guys be P1, so that's the distribution of P1 hat for the
Mhm.
males. And for the females, they have their own proportion going on.
Yeah. It was
It'd be around
0.6,
0.60, the true value.
and I believe 0.023 was
Right.
the standard deviation. Remember, you do that. Standard deviation was PQ over N.
Okay,
So 0.6 times 0.4 divided by our 450.
super. Now, this is why we're talking about difference of normal curves. We
Yes.
have 2 normal curves here. P1 hat has a normal distribution.
Mm-hmm.
P2 hat has a normal distribution.
So
So when we subtract them,
it has a normal
it
distribution.
has a normal distribution. So
Yes, it
this is
does.
P1 hat minus P2 hat.
Mm-hmm.
And the expected value would be what you get when you subtract those.
Right.
Which is-
Negative 0.03.
Right. And then when you calculate the standard deviation, you have to do what we did before. You have to add the variances
Yes.
and square root them.
And when you do that, you should get 0.037.
All right. Now this is going to be the foundational fact for a couple of days. We're going to do confidence intervals like we did in the past, hypothesis testing.
Mm-hmm.
The main idea is right here, that the difference in proportions has a normal distribution, given that some conditions are true.
Yes. All right. So
Last question.
looking at the probability for it,
Last part of the last
if we
question.
normal CDF'd it, okay, we should get 0.21 because we want norm CDF, and it was greater than the one for females, so that would mean we want 0 and bigger because females were bigger.
Yeah, so
Okay.
let's write this out. Let's write the math for what we're looking here. So what it's really asking is that proportion of males greater than females. So that means P1 hat minus P2 hat is greater than 0. So it's not quite obvious, but if we want males bigger than females, we could say P1 greater than P2, but that's not the variable we have.
Right.
The variable we have is P1 minus P2.
Mhm.
Okay, so in terms of what we have, we need that to be greater than 0 for the males to be bigger. And then that's the command we could do it. There's a 21% chance
That our males are bigger.
that the proportion males bigger.
Yep.
I think the males were watching American Sniper more than Birdman.
It's possible.
I don't know.
All right. So now your turn. So here we have X with the normal distribution, mean 27, standard deviation of 6. Y has a normal distribution with mean 20 and standard deviation of 4. So find the difference in expected value in standard deviation, sketch it, and then find the probability that the difference is greater than 10.
Cool.
Sounds good. All right.